Hello everyone, welcome back to the solutions for the past year questions on the 6th term examination problems. And as usual, we are looking into various different questions so that we just can cover all the bases of different chapters. Alright, we want to go through as many different varieties of topics as possible, and that is why I'm not taking these questions in any particular order. Alright, so this question is on a mixture of coordinate geometry as well as quadratic equations, simultaneous equations, and so on. We have done a few sums and equations, but this is a mixture from coordinate geometry, so I decided to pick this one up. Alright, also some of the questions are on, especially in coordinate geometry, they ask you to draw diagrams. Now, asking to draw diagrams is easier when you are doing the questions yourself, but if I'm trying to show it to you, I will not be able to show the exact process of drawing the diagrams, right? Because I look at the equations and then I figure some things out on my own and then I draw the diagram, right? So when I'm drawing the diagram, it's nothing that I can teach you, right? You just have to know the process, right? You either differentiate it and get the inflection points and then check whether it's increasing or decreasing and you draw the graph. So I'm not selecting those problems in which you have to specifically draw a graph and that is the entire problem. Okay, so in this question you may or may not draw a graph. If you can visualize the ellipses, then it's more than enough. Alright, so what is the question? Show that the equation of any circle passing through the point of intersection of the ellipse, and the ellipse can be written in the form of something something. Okay, so that means there is a squished ellipse and a larger ellipse. So if two ellipses intersect, they will intersect at two different points. We have to pass the circle through those two intersection points. Alright, now these could intersect in any way. Okay, which way they will intersect, that we can infer from the diagrams, but just so you know that it can be like this. There is an ellipse like this, there is another ellipse like this, so something like these points that are getting intersected, so you have to draw a circle through here and then you have to figure out the equation of the circle. So this is something that we will figure out how these ellipses look like. Alright, now you know that how we read the center and the length of axis of the ellipse. It's quite easy, right? So if the equation is x plus 2 whole square plus 2y square equal to 18, this gives us the information that the center of the ellipse is at x plus 2, right? So it will be minus 2 and y has no associated coordinates, so minus 2 comma 0. And length of axis, so the major axis and the minor axis, right? That we have to calculate. Since we do not exactly know the orientation of the ellipse without drawing it, I'll just say the length of the axis in the x direction and the y direction. Alright, I'll not designate it as major or minor because to classify that fully we would have to sketch out the diagram. Alright, so I'll just say x, well, I cannot say x axis, right? So axis in the direction of x, that will be much better, right? Oh, okay, I'll calculate the semi axis then, so that will help us avoid the ambiguity. Semi x axis, so this will be equal to, there is no coefficient in x, right? So I'm sorry, so this will be equal to just root over of 18, because this is usually x square plus y square equal to a square format of the general ellipse, right? So since this is in a square format, that would have been, the total length of the axis would be 2a and 2b, isn't it? If it is x minus a whole square, if it is x plus a whole square, sorry, or if it is written as x by a whole square plus y by b whole square equal to 1, then it's 2a and 2b, isn't it? So I hope you remember the general form of an ellipse, and using that we can just write here root 18, which is equal to 3 root 2. That means it will stretch from minus 2 comma 0, 3 root 2 units to the right and 3 root 2 units to the left. Alright, now we can calculate the semi y axis as well. This will be basically the division, right? So root over of 18 by 2, which is 3. That means 3 units up and 3 units down. Now we can actually understand whether this is a major axis or minor axis. So the major axis is a longer one, right? So this will be the major axis. Now I can classify it. semi major. I'll need a bit more space. And this is the semi minor axis. Alright, so semi major axis and semi minor axis. Similarly, we can look into the next one. 9 into x minus 1 whole square plus 16y square equal to 25. So this will give us a center of 1 comma 0, right? And we'll calculate the first axis. We don't know which one is it, major or minor. So this will be root over of 25 by 9, right? So that will be 5 by 3. And then the other axis will be root over of 25 by 16, which would be 5 by 4. Now if denominator is shorter, fraction will be larger, right? So this is the semi-major axis again. Why do I keep making the same mistake? Okay. And this will be the semi-minor. Okay, so we know a bit about the ellipses. From this particular stage, you could draw the ellipse if you want. It might have been a part of the question also in some other exam, but here it is not, so we don't need to worry about it. Now, what do we need to actually worry about it is the point of solutions. Now, how do we solve the ellipses? We have to just solve these two equations simultaneously, right? Simultaneous quadratic equations. We had done it previously in one of our videos. Let us do it again. So this is equation 1 for us, this is equation 2 for us, and now we should be able to solve them, right? Let us multiply equation 1 by 8. So this is 8 into 1 minus 2. So that would give us 8 into x plus 2 whole square plus 16y square equal to 18/8. So this is 144. And this is 9 into x minus 1 whole square plus 16y square equal to 25. Subtract them. I end up with 8 into x plus 2 whole square minus 9 into x minus 1 whole square is equal to, this should give us 119, right? That is the equation. Now there are no clever ways to go around these apart from expanding. So this will be 8x square plus 4, 32x, right? 2 square 4s, 8 4s are 32 again, minus 9x square minus 2x minus plus 18x, 1 square plus 9. I hope I have done the calculations correctly. I have 119. Now this will give me x square. If I simplify it, I'll get x square minus 50x, right? 32 plus 18, 50, and plus 96 equal to 0. Well, this is easy to solve. 96 is 48 into 2. So this will give me x minus 2 into x plus 4, sorry, x minus 48 equal to 0. Now here we have two solutions, x equal to 2 and 48. Now x equal to 2 is possible, right? X equal to 48 is not possible. Why? Because my center of the first ellipse is at minus 2 comma 0, okay, and the center of the next ellipse is at 1 comma 0, okay, so these are very near to the origin, and then the axes are 3 root 2 units away, 3 units away, 5 by 3 and 5 by 4. So these are very small numbers. I cannot have the intersection of these two ellipses at x equal to 48. Alright, these ellipses are not that long. Then why do we get this value? Because not all the values here are real, right? We are only taking the real values. So there are some complex values. So corresponding to x equal to 48, you might get some complex values where the ellipses are intersecting. But we'll just deal with the real ones since we just have to work in the R2 plane. Alright? So take x equal to 2. Just write x equal to 48 is inadmissible. due to complex points. Alright, so if x is equal to 2, then we can calculate y, right? Let's put it in any one of the equations. Let's put it in this one, first one. What do we have? We have 2 plus 2 whole square plus 2y square equal to 18. So 16 minus 18, 2y square equal to 2, which gives me y equal to plus minus 1. Right, so I get two values of y. So that means points of intersection are 2 comma 1 and 2 comma minus 1. Okay, so if I draw them above the x-axis, I'm not drawing the ellipses, but the points of intersection will be 2 comma 1. Okay, this looks more like 1 comma 2. So 2 comma 1 and 2 comma minus 1. Now if the circle passes through both of these points, it's clear that the center of the circle will be the midpoint of the line joining between these two. Now the line joining between these two are perpendicular to the axis, right? Because the abscissa of the 2 points are the same, just the ordinates differ. So the center will basically be the midpoint of these two, which is 2 plus 2 by 2 comma 1 minus 1 by 2, which is 2 comma 0, right? So this is in the a comma 0 format. Remember this will be very useful. Okay, so okay, before we proceed, we just need to check one thing, that these points of intersection actually satisfy both the ellipse. So take 2 comma 1. If we put 2 comma 1 in the first equation, I'll get 2 plus 2 whole square, which is 16, plus 1 square, which will give me 18. Fine. 2 comma minus 1 will work in the same way, because y square of minus 1 square will give me again plus 1, which is 16 plus 2 equal to 18. Fine. Second equation, 9 into 2 minus 1 whole square, right? So 9 plus y 1 will give me 9 plus 16 equal to 25, which is true. If y equal to minus 1, then 9 into 16 into minus 1 square is also 16, which is 9 plus 16 to 25. So these two values are satisfying the equation, which there is no doubt about. Okay, so these are the points of intersection. There will be two more points of intersection, but those will be complex. That is why we rejected x equal to 48. Alright, so now what will be the equation of the circle that passes through these points? So since this is of the a comma 0 format, I can write equation of the circle. This is basically in the format of x minus a whole square plus y minus b whole square equal to r square, right? Now I can just use this a comma 0 format and write it as x minus a whole square plus y minus 0 whole square, and this one will be r square. So r square is the distance between the center, which is a comma 0 in this, and any one of these 2 points. So the distance there would be a minus 2 whole square, right? I can use the distance formula, plus 0 minus 1 or 1. So this becomes x square minus 2ax plus a square plus y square is equal to a square minus 2a plus 4 plus 1. So I think a square gets cancelled, yeah, and I get x square. What do I have to? Okay, so this is not 2a, this is 4a. Now this becomes x square minus 2ax plus y square equal to 5 minus 4a, right? Exactly what we had to prove. So this is done. Now here we had to do a bit of manipulation, because we actually know the value of a to be 2, right? So if we want to calculate the exact equation of the ellipse of the circle that passes through the intersection of the ellipse, we can. But the objective of this problem was not to get the exact equation, it was to find the locus of all of them. Alright, so wherever the points of intersection lie, I can substitute the value of the midpoint between those two and get the equation this way. Alright, of course it will not be true because I have calculated the radius also from this point, so I'll have to change the right hand side. But if I make those two adjustments, I can arrive at this. Okay, see, not all results that you obtain for proving a certain thing in a examination will be useful, right? This does not give us any useful information about the in about the radius of the circle or the nature of the circle. Well, circle is always circular. By nature I mean the equation of the circle. It would be much more useful if we could put the value of a. That would give us x square minus 4x plus y square equal to 1. That would inform us how the circle looks like much easier rather than this weird equation. Okay, but then again, that's what they want us to prove an identity, so we did that. All right, the main way of proving this would be to identify that this lies in a comma 0 format. Okay, otherwise you might be confused where this a came from, because nowhere has it been mentioned what a is, isn't it? And both of the formulas of circle and ellipse contain a, because ellipse is x by a whole square plus y by b whole square equal to 1, right? There is an a, and circle is the formula in green that I wrote, x minus a whole square plus y minus b whole square equal to r square. There are a's in the general formula for both of these diagrams, but a in the context of this problem is not defined. Okay, sometimes they will leave you with a open-ended question like this, so that you have to think a bit about the way in which you will proceed. Alright, this is the beauty of the problem, and this is the weirdness of the problem also, because a is not defined. Alright, fine. With that being said, I will end the video here, but if you have any queries about this course or the exam or its problems, feel free to contact this number via WhatsApp. Our team will get back to you. If you want, you can leave your comment, suggestion and feedback in the comment section of this video as well, but many of you do not prefer to use YouTube for commenting. No issues, you can use this number as a WhatsApp number. Alright, you will get a reply and our team will ensure that your doubts are solved. Okay, so I'll stop this video here. Thank you all for joining, and I'll see you in the next past year question.